On behalf of the planning team, which includes representatives of the USDA, Natural Resources Conservation Service, the Georgia Soil and Water Conservation Commission, the Upper Chattahoochee River Soil and Water Conservation District, and Schnabel Engineering, we thank you for your interest in the planning study for Settingdown Creek Dam No. 56. This is the second public meeting in the development of the Supplemental Watershed Plan environmental assessment for this dam. The purpose of this planning study is to assess the Settingdown Creek Dam No. 56 watershed, to evaluate the performance of the existing watershed structure, to develop a plan to address compliance issues, to determine if federal financial assistance will be available to address compliance issues, and to determine if the project sponsors would like to continue operation of the dam within the NRCS watershed program. As part of the planning study, there is a public participation plan. The objective is to inform the public and watershed stakeholders of the planning effort. The planning study requires a series of public meetings. The initial public meeting was provided in August of 2020 and included a brief history of the NRCS watershed program, a brief history of dam safety, considerations for dam design, operation, and maintenance, an overview of the Settingdown Creek watershed and specific dams included in the planning study, and a solicitation of questions and comments for the scoping topics and opportunities and concerns associated with this planning effort. We would like to note that if you were unable to view the initial public meeting presentation, it has been reposted to Schnabel's YouTube channel for anyone interested in viewing the presentation and the content described above. This presentation, along with the initial public meeting presentation, will be available until early January 2021 for review and comment. During the second public meeting presentation, an overview of the Settingdown Creek watershed and specific dams included in the planning study will be reiterated. Additionally, existing conditions associated with the Settingdown Creek Dam No. 56 will be discussed. A discussion of rehabilitation alternatives under consideration for the dam and an opportunity to solicit questions and comments will also be available at the end of the presentation. The Settingdown Creek watershed is located in northern Forsyth County, Georgia. Settingdown Creek is a tributary of the Etowah River, which flows into the Coosa River near Rome, Georgia. The watershed contains over 34,000 acres of drainage area. The original watershed work plan, prepared in April 1954, provided for the construction of 15 floodwater retarding structures or dams within the Settingdown Creek watershed. This slide provides an aerial photograph of the Settingdown Creek watershed. For reference, please note the location of Georgia 400 or US Highway 19 near the right or east side of the map. Also for reference, in northern Forsyth are the locations of Keith Bridge Road, Dahlonega Highway, Highway 9, Matt Highway, Georgia 369, Post Road, and Canton Highway, Georgia Highway 20. This slide indicates the location of the Settingdown Creek watershed overlaid on 1963 aerial photography. This aerial photography shows what the land uses were during or right after the construction of several of the Settingdown Creek watershed dams. As you can see, a significant amount of commercial and residential development has occurred within the watershed over the past 60 years, which will impact the performance of the dams. Focal points of the analysis and study for the Settingdown Creek Supplemental Watershed Plan include upstream areas. We are concerned with identifying upstream flooding limits as well as the need for additional storage capacity. Also in the study are downstream areas, which could be impacted by flooding or the breach of the dam were it to fail in a catastrophic manner. We've also taken a look at the existing hydraulic capacity of the spillway outlet works, and we've performed several different storm scenarios to evaluate the performance of the dam during those storm events. In addition to the engineering analysis that has been performed and is being performed, an economic and social benefits evaluation is also underway. Finally, the environmental assessment portion of the study includes an assessment of streams and wetlands, as well as any threatened, endangered, or protected species in the vicinity of the dams, as well as a cultural resources survey to determine if there are any structures or items of historic significance that would be impacted by a rehabilitation of the dams. Once again, here's a map of the Settingdown Creek watershed. The 6 dams that are currently being studied are highlighted in various colors. The majority of the dams in this study, the 5 to be exact, are located at the very upstream end of the Settingdown Creek watershed. Settingdown Creek Dam No. 56 meets Georgia Safe Dams Program criteria to be considered a Category 1 or high hazard dam. This means that failure or improper operation of the dam would likely result in the loss of human life. The dam needs an operating permit from the Safe Dams Program. Previous assessments of this dam indicate that it does not comply with current SDP rules and requirements. The dam is not exempt from these rules and requirements. One purpose of the Supplemental Watershed Planning Study is to determine if federal assistance will be available to bring the dam into compliance with current dam safety requirements. The Georgia Safe Dams Program is fully aware of this dam, its classification or pending classification as a high hazard dam, and that the dam is being studied by the planning team. Some of the original design features of the dam include that the dam was not originally designed as a high hazard dam. Its original purpose and primary purpose is flood mitigation. An anticipated secondary purpose of the dam is sediment accumulation and storage. The dam includes a reinforced concrete principal spillway, pipe, and riser system. The riser is located in the lake and conveys flows into a pipe or conduit from the lake through the embankment to the outlet channel downstream of the dam. Additionally, a vegetated earthen auxiliary or emergency spillway is located below the crest of the dam elevation in the event that high flows are encountered, so that flows can pass around the crest of the dam without the dam overtopping. Once again, the Settingdown Creek watershed map is shown. The location of Settingdown Creek Dam No. 56 is highlighted in yellow. Note that it is located near the upstream end of the Settingdown Creek watershed. Dam No. 56 is located west of Georgia 400, north of Hubbardtown Road, and south of Plainsman Circle. The dam was built in 1954 and is approximately 66 years old. The dam is approximately 33 feet tall and has a drainage area of just under 1 square mile. The design total storage capacity of the dam is 283 acre-feet, with considerations for sediment storage, flood control storage, and surcharge. Here's an aerial photo from 1956 showing the location of the dam shortly after its construction and impoundment of the lake. Since 1956, a considerable amount of development has occurred upstream and around the dam. Note the location of the residential subdivision adjacent to the lake. As part of the study, a survey was performed this summer of the dam to verify elevations of the dam crest and spillway outlet works. Note that this survey has been oriented with the lake at the bottom of the page and the downstream areas at the top of the page. This is a common practice in dam engineering and allows those with knowledge of dam engineering to orient themselves with regard to a dam. When you are standing on the crest of the dam with the lake at your back and the downstream areas in front of you, the left and right ends of the dam are referenced in this manner. The aerial photo taken to support this topographic survey was taken after clearing activities were performed this summer of 2020 to remove trees and inappropriate vegetation from the downstream slope of the dam. This slide shows a site plan of the existing dam and spillways. Note that the existing principal spillway is located near the left end of the dam, and the auxiliary spillway is located near the right end of the dam. We have a couple of photos of the existing Settingdown Creek Dam No. 56. The first photo shows the locations of the concrete riser structure, the upstream slope, and the crest of the dam. At the top right of the photo, you can see some of the homes in the residential subdivision located upstream of the lake. This photo shows the downstream portions of the dam and spillway. The plunge pool is located in the foreground near the left of the photo. The principal spillway conduit is indicated with water flowing through it, and the downstream slope of the dam is also indicated. Part of the planning study includes an environmental assessment of the dam and its adjacent areas. An environmental survey was performed for Dam No. 56. An aquatic resource survey map has been shown on this slide to indicate the locations of streams, wetlands, open water, and the survey area. The survey team found no protected species during the survey. Some invasive species, predominantly Chinese privet, were identified, and those locations are also indicated on the aquatic resource survey. Also, as part of the environmental assessment, a Phase 1 cultural resources survey was performed. This survey included literature review and field activities, including shovel tests. The results of the study found that no archaeological resources were recorded. The dam, approximately 66 years old, is the only historic resource, but it is not eligible for the National Registry of Historic Places. The Cultural Resources team recommended that no additional work be performed for this dam. This slide shows a dam breach inundation map and the location of downstream hazards that could be impacted in the event of a catastrophic failure of the dam. The dam breach analysis was performed using sunny day parameters with water at the top of the dam. This is a common configuration or analysis method for NRCS flood control dams. This slide has a downstream flood analysis map included. This map includes the upper portions of the Settingdown Creek Watershed located upstream of John Boris Road. Note that not only the 5 dams included in this study are shown on the map, but also a couple of other dams, Settingdown 10 and 21, are also indicated to determine the flood limits during a variety of storm events. The flood limits for the 100-year and 500-year storm events are indicated on this map. Downstream flood analysis is important as we develop rehabilitation alternatives and scenarios for these dams, because the dams currently provide some level of flood benefits to downstream areas, and their removal or modification could impact the benefits that are currently provided. This map indicates the upstream flood limits associated with the dam. During the engineering analyses performed for this dam, the spillway outlet works and storage were modeled, and several storm events were run through the dam and spillway outlet works. This map indicates the contour elevations associated with the existing normal pool elevation of the lake, the auxiliary spillway control section, and the dam crest elevation. Additionally, water surface elevation limits associated with the 100-year storm, the 500-year storm, the Safe Dams Program design storm, which is currently the 1/3 probable maximum precipitation, which is 30 inches of rain in 6 hours, and the freeboard hydrograph, or FBH storm event, which is the NRCS design storm event for the dam, which is 100% of the probable maximum precipitation. Note that there are a couple of structures that would be impacted by the design storm events should the watershed experience those events. During the engineering analysis and archival review for this dam, several existing dam deficiencies were identified. Operations and maintenance issues include that the normal pool elevation of the lake was raised by approximately 11 feet in the 1970s without authorization. This impacts the design flood control benefits intended for the original dam. In the summer of 2020, the dam was recently cleared of trees and inappropriate vegetation, and an appropriate turf grass was reestablished on the embankment. An underwater inspection of the riser structure was performed by commercial divers and concluded that portions of the slide gate assembly are worn and/or corroded. Additionally, portions of the riser concrete are cracked and/or spalled. A CCTV inspection of the principal spillway conduit interior is pending, and upon the results of that inspection, decisions can be made whether or not the pipe is of soundness to continue serving the dam. Existing hydraulic deficiencies include Safe Dams Program criteria not being met. During the SDP design storm event, which is currently 1/3 of the probable maximum precipitation, or about 10 inches of rain in 6 hours, the dam overtops by 1 foot and the auxiliary spillway breaches. Please note that in meeting the requirements of the SDP design storm, the height of the dam may need to be raised, which would result in the design storm changing from the 1/3 PMP to the 1/2 PMP. Regarding NRCS criteria, the auxiliary spillway engages prior to the PSH storm event. The auxiliary spillway control section is about 2 feet lower than it's required to be, and during the NRCS design storm, which is 100% of the PMP, or 30 inches of rain in 6 hours, the dam overtops by 3.1 feet and the auxiliary spillway breaches. The planning team is considering several rehabilitation alternatives based on NRCS planning procedures. The first alternative is the future without project or no action alternative. This assumes that no federally financed rehabilitation alternative will be available. So rehabilitation funding for this alternative would come from state or local sources. This alternative would utilize the criteria developed by the Georgia Safe Dams Program for a high hazard dam rather than NRCS criteria. Another alternative that is being considered is decommissioning the dam. This involves the removal of a portion or entirety of the existing earthen embankment, stabilization of the excavated channel and resulting lake bed, and it may also require floodproofing and/or relocation of downstream hazards. Structural rehabilitation alternatives would meet NRCS criteria. They would include embankment improvements, the construction of a new principal spillway, and the construction or modification of the existing auxiliary spillway. Auxiliary spillways could be earth cut, labyrinth crested concrete spillways, or RCC step spillways with either a broad or OG crest. The development of NRCS rehabilitation alternatives includes consideration of upstream non-flood control ponds as well as uncertainties associated with climate change and what rain events may be in the next 50 to 100 years, which would be the projected lifespan of the dam after rehabilitation. The first alternative that we will review is the no action alternative, which would meet Safe Dams program criteria for a high hazard dam. The dam would have to be raised to provide adequate freeboard, which would result in the design storm increasing from 1/3 of the PMP to 1/2 of the PMP based on height requirements established by the Georgia Safe Dams program. The upstream and downstream slopes would be regraded to 3:1, and a riprap lined wave berm would be constructed along the upstream shoreline of the dam. The existing vegetated spillway would be decommissioned by placing fill up to the crest of the dam elevation. The principal spillway would be rehabilitated by decommissioning the existing spillway and constructing a new spillway riser structure that would return the normal pool elevation to its originally designed level, which is approximately 11 feet lower than it currently is today. A new principal spillway conduit would be installed, and a riprap lined plunge pool would be constructed at the downstream end of the conduit. The auxiliary spillway to service the Safe Dams program storm event would need to be 56 feet wide, consisting of 2 Labyrinth cycles of equal width. The spillway would be constructed over the embankment with consideration to access both sides of the spillway from the dam crest. Finally, the concrete spillway would include a stilling basin and riprap lined apron to dissipate energy associated with high flow storm events. This slide shows a conceptual layout of the Labyrinth spillway necessary to meet SDP criteria. Note that the principal spillway would be reconstructed or replaced, and that a new Labyrinth crested spillway would be constructed over the embankment. This view shows a profile view of the Labyrinth spillway. The Labyrinth would flow during periods of high flows, typically greater than the 100 or 500-year storm event. Water from the spilling over the Labyrinth spillway would flow down the chute and into the stilling basin and into the riprap lined apron downstream before being returned to the original stream channel downstream of the dam. The first NRCS structural alternative that was considered involved a vegetated auxiliary spillway alternative. This alternative was considered and determined to be infeasible due to the nature of the modifications to the vegetated auxiliary spillway necessary to meet NRCS requirements. This means that based on NRCS requirements, an excessive amount of raising or widening of the auxiliary spillway would be required to meet and pass the NRCS design storm criteria without the dam overtopping or without the auxiliary spillway breaching due to high flows and erodibility. A decommissioning alternative is also being considered by the planning team. This alternative would involve reconfiguring the existing structure so that it would no longer be classified as a dam. The process is more involved than simply breaching the dam. Decommissioning the structure would involve removal of most or all of the existing dam, reconnecting the grade of the original floodplain, stabilizing the resulting lake bed with permanent vegetation, stabilizing the primary channel through the footprint of the old dam with riprap. While decommissioning the structure would improve flooding upstream of the dam, the downstream flood benefits provided by the dam would be lessened. The planning team is currently evaluating and quantifying the downstream benefits provided by the dam, as well as the loss of those benefits were the dam to be removed. This slide provides the conceptual site plan of the removal of the dam and the reconnection of the floodplain downstream of the dam with the lake bed. This alternative would also include stabilization of the lake bed with vegetation and lining of the original stream channel through the footprint of the dam with riprap. Here are a couple of additional profiles that show what the excavation of the dam and reconnection of the floodplain would entail. Here's an example photograph of a breached dam with a riprap lined stabilization channel running through it. Removal of a dam would take away the flood benefits provided by that dam, and any rain that accumulates in the watershed and reaches the dam area would likely flow out at a 1-to-1 ratio. Whatever flows in would also flow out without any storage or attenuation. The first NRCS structural alternative that we will discuss is the Labyrinth Spillway Alternative. Similar to the Safe Dams Program alternative, the embankment would need to be rehabilitated by raising the crest of the dam to the current maximum water surface elevation associated with the design storm, which is 100% of the PMP. The upstream and downstream slopes will be flattened or regraded to 3-to-1. The riprap lined wave berm would be included, and the existing vegetated auxiliary spillway would decommission by closing it off with fill. Additionally, a new principal spillway would be constructed, including a pipe and riser and a riprap lined plunge pool. The existing principal spillway system would be decommissioned or removed. The auxiliary spillway in this alternative involves a 120-foot wide labyrinth crested chute spillway. The labyrinth would involve 5 cycles of equal widths, with consideration given to crossing from one side of the embankment to the other from the dam crest. The spillway would also have a stilling basin and a riprap lined apron to dissipate energy associated with high flow storm events. This slide includes a conceptual layout of the Labyrinth spillway that would meet NRCS design storm criteria for this dam. Note the location of the spillway over the dam embankment and the need to decommission the existing principal spillway and construct a new principal spillway to service the dam. The auxiliary spillway, currently located on the right end of the dam, would be decommissioned by filling it up to the dam crest elevation. This view shows a profile of the Labyrinth spillway. Similar to the Safe Dams Program spillway, water would cascade over the labyrinth walls and down the chute into a stilling basin where the energy would be dissipated and water flowing through the spillway would be returned to the original stream channel and floodplain. Here's an example photograph of a labyrinth spillway. Note that this spillway has been constructed over the dam embankment and a bridge has been used to cross from one side of the crest to the other, since the spillway bisects the dam. This view also shows how flows from the auxiliary spillway are reconnected to the downstream outlet channel that's already existing. Here's one more example photograph of a labyrinth spillway. This spillway was designed to have the principal spillway pipe penetrate the chute so that flows through the principal spillway would discharge into the auxiliary spillway's stilling basin. Consideration for crossing this dam has been provided on the upstream end of the dam, and vehicular traffic is available around the upstream side of the dam during periods of no rainfall or normal pool conditions. The final structural spillway alternative that we'll discuss today that meets NRCS design criteria is an RCC or roller compacted concrete spillway. It would involve the same embankment and principal spillway rehabilitation activities as the Labyrinth spillway. The difference would be the auxiliary spillway would be constructed of roller compacted concrete and would be a step spillway with an OG crest. An OG spillway is a straight weir that has a rounded top to improve hydraulic performance and flow during high storm events. The spillway would need to be about 295 feet wide, and RCC steps would be constructed with a 1 foot thickness. As with the other alternatives, consideration has been given to providing access to both sides of the spillway from the dam crest. The spillway would also include a stilling basin and riprap apron at the downstream end. This slide shows a conceptual layout of the RCC spillway. Note that it is also constructed over the existing embankment and is considerably wider than the Labyrinth spillway that would meet the same requirements. This slide shows a profile view of the RCC spillway. Note that the RCC steps are sloped at 3:1 with 1 foot step increments. At the top of the spillway is the OG weir, which is a rounded weir, and it would convey high flow events in excess of the 100 or 500-year storm events. Note that the principal spillway in this view has also been shown to penetrate through the step spillway and discharge into the proposed stilling basin. Here's an example photograph of an RCC step spillway. This spillway has a straight weir or a broad-crested weir without an OG, and water flowing through this would cascade down the steps and into the stilling basin, which has been covered in topsoil to improve maintenance. Recall that this spillway does not flow all the time, only during very infrequent storm events, such as the 100 or 500-year storm event. So several dam owners with RCC spillways are happy to fill portions of the spillway with topsoil and regrass those areas to improve long-term maintenance and appearance of those spillways. This is another example of an RCC spillway. This one has an OG crest, but as discussed previously, the downstream stilling basin and steps on the step portion of the spillway have been covered with topsoil and grass to improve maintenance and appearance. Here's a view of the crest of the OG. Note that the crest is rounded to improve the hydraulic performance. The final photo here shows another RCC step spillway that has been covered with topsoil and grass. This principal spillway has been designed to penetrate through the RCC steps and is flowing into the stilling basin downstream of the RCC spillway. This photograph was taken during construction before vegetation had had a chance to establish, but over the period of a few months, this vegetation did establish and is now covering the stepped portion of the spillway. At this time, we would like to welcome you to publicly participate in the planning study by providing your questions, comments, and concerns about the planning study and the alternatives being considered. We invite you to submit questions, concerns, and comments to the link using the link provided below that will take you to a Google form. Questions, concerns, and comments associated with this public meeting will be accepted through Monday, January the 4th, 2021. Once again, we would like to thank you for your interest and participation in this planning study and invite you to participate in the public participation plan by submitting your questions and comments for this planning study. Thank you once again and have a good day.